Hello everyone. So we'll start this session, but before that, we will wait for everyone to join. So yeah.
टी शर्ट्स तो हम सब पहनते हैं लेकिन
Hello, hello. Yeah, so today will be so there is no students today joining today, but yeah, so I will be discussing all the things that is covered in this week, and I'll try to cover as much as possible. But yeah, I'll see if yeah, I'll upload this video to the YouTube, and if you haven't attended this live session, you will still be able to attend this thing online on the YouTube. I hope you like it. Yeah, so let me just start my tablet and I'll explain all these things from my tablet. Okay, so this is week 5 of the content, and in this week we'll start with TCP congestion control, socket programming, and yeah, these two things will cover. So we were going to the TCP socket programming, like it's just focus about TCP's. Let me see the content in this week. Um, yeah, the transmission control protocol or the congestion control protocol. Uh, so in the TCP congestion control protocol, I don't think. Yeah, so what you have already seen is that, let's say there is a client and server, and each client and server has some windows to store data. Let's say the server has 4 KB of windows. The client send 2 KB of data. So in response, the server will send the acknowledgement for that first. and this 2 KB is occupied now. Another 2 is left. The server, what it will do is that it will advertise a window size of 2 KB. Okay. So let's say the client sent another 2 KB of data, and the server gives an acknowledgement of 1 and window size of 0, because now the window is all covered. So this is 2 KB and this is 2 KB. So yeah, the server will respond with the window size as 0, and it will not be able to proceed further. Like, so speaking of this, once it is 0, so the client will be blocked. So we'll block the client for certain amount of time period, let's say T. And once this data is consumed by the application layer, let's say 2 KB of data is consumed by the application layer, what will happen is that it will advertise another 2 KB of uh, storage to the client, and the client, let's say, sends 1 KB of data to the server, and it will again take 3 KB of data in total. So in this way, like, the congestion is managed in the TCP layer. But yeah, so we'll not discuss more on this. We'll move to the socket programming part. Uh, yeah. So if you have any doubts or something, you can ping me. So, so I will be covering the socket programming now. Um, so I'll be sharing my screen here. Let me um open a VS Code. I'll new in the okay. So new folder. Cancel file, new window, open folder, and Iceland. Let me see. Then KMRF, new folder. Open. Yeah, so I'll okay, so let me share my screen now. Um, where is- yeah, so let me first create. Yeah, so let me first tell you about the socket programming. The socket programming like was started back in 1971, and today, although the underlying protocols used by the socket API have evolved over the years, now the new ones have developed. The low level API has remained the same. The most common type of socket application are client server application, where one sided act as a server and await for the connection from the client. This is a type of application that you will be creating in this tutorial. And more specifically, you will focus on the socket API for internet sockets, sometimes called Berkeley or BHD sockets. Um, there are also Unix domain sockets, which can only be used to communicate between processes on the same host. But I'm not going to cover that. Okay. The Python's socket module provide an interface to the Berkeley socket API, and this is the module that you will learn in this tutorial. The primary socket API and the methods are in the module are like there is a socket method, there is a bind method, there is a listen method, there is accept, connect, then connect X, send, receive, and close. Python provides a convenient and consistent API that maps directly to the system calls, their C counterparts. In the next section, you will learn how to use this together. Okay. So as part of the standard library, Python also has classes that make use these low-level socket functions easier. Although it is not covered in this tutorial, you can check out the socket server module, a framework for network servers. There are also many modules available that implement high-level internet protocols like HTTP and SMTP for overview internet protocols and support. TCP sockets. Okay, so you're going to create a TCP socket object using socket.socket, specifying the socket type as a sock.sockstream. When you do that, the default protocol that's used in the transmission control protocol is a good default and probably what you want. Okay. Should I did I tell you about the TCP and UDP? So there are two type of transmission control protocol. One is TCP and is UDP. So I think I covered it last time as well. So TCP ones are the transmission control protocol, which is a reliable source of connection. So a connection is established first. The resources are reserved first. Then you transfer the data between two parties. And UDP is somewhat more, I would say, it's more. It will be somewhat more like instantaneous, like when you want the data to be gone and don't really want the interaction and stuff, you know. For example, like when you are sending the um, HD videos across network, and when you're streaming HD videos in YouTube, what you do is that you the connection type is TCP because you want each and every packet sent and received reliably to render the image in a very high quality manner. But when it comes to a 360p or 480p image or 480p streaming or video, you don't want each packet to reach. You just want approximately all the packet to reach. Like the image should form, but it need not to be clear. Okay, so so that's the idea behind the TCP and UDP connection, where TCP uh, uh, where TCP is a reliable and stateful connection, and the UDP is a more stateless and non-reliable connection. So uh, yeah, the TCP is reliable. Packets dropped in the network are detected and retransmitted by the sender, and has in-order data delivery. Like data is read by the application in the order it was written by the sender. Okay. In contrast, the UDP sockets created with sock.sock.dgrm aren't reliable. The data read by the receiver can be out of order from the sender's write. Why is this important? Network are the best effort are a best effort delivery system. There is no guarantee that your data will be reach its destination or that you will receive that what's been sent to you. Network devices such as routers and switches have finite bandwidth available and come with their own inherent system limitations. They have CPUs, memory, bus, and interface packet buffers, just like your client and servers. TCP relieves you from having to worry about packet loss, out of order data arrival, um, and the other pitfall that invariably happens when you are communicating across a network. To better understand this, check out the sequences of socket API calls and data flow for TCP. Okay, so I'm going to draw this out in a bit. Okay, so let me start with um, the first um, client and server interaction that is called echo server. Uh, so
So echo server is like, echo server is it's a server which sort of echoes back what you say. Like if you say hi, the server will send you back the hi. Okay. So let me start with echo server.py, and there is uh, yep. So we just generated this code, but I will explain all these things to you in a minute. Okay. So let's start with the echo server. Okay. So echo server sort of echoes back what you are saying. So let's start with the server. So the library that we're going to use for socket programming is called socket. Okay. It's not a big thing, and we will use, yeah. So it's an inbuilt library. You don't have to worry about why this library and how to install this and stuff. So it's an inbuilt library within itself. Okay. So let me just increase the font a bit. Let me go to the settings, and font font size is 16. Let me make it 18, and bah, yeah. So I think it's visible now. I think it will be visible if it's in a mobile screen as well. Okay. Perfect. So we are thinking about the um yeah. So the socket. So first, we need to import the socket. Okay. And so what is a socket? The socket is, I'll just uh, exit, exit, delete. Okay, so what is socket? So socket is, I would say socket is a um, combination of IP and port number. For example, uh, 127 dot 127 dot 0 dot 0 dot 1 then dot 0 dot 1. Yes. So this is socket like 127.0.0.1. It's the IP, and 10,000 is a port number. So the combination of it we call the socket. Okay. So creating a TCP IP socket. So this is socket. So socket, sock.af inet. So af inet is the type. Uh, the socket type is af inet. Um, so the is the internet address family for IPv4, and sock stream is the socket type for TCP. Okay. And this TCP type is something called we call like so this, since we are using TCP, it is S stream. If we will be using UDP, it will be something different. I'll let you know. It will be D stream. Okay, it will be D stream. Sock D stream. Let me check once. Um, yeah, we'll get back to that. Okay, so we're creating a socket. Socket is like uh, uh, you're creating a socket that will specify a IP address and host, IP address and port for it. So bind the socket to the address given on the command line. So the next thing what we are doing is that we are binding the socket to uh, um, yeah. So you're binding. So you're creating an object, and you're binding this as your binding the socket to the address given on the command line. So you are creating a socket object, and you are specifying the what is the socket thing, like what is the IP and the port of the socket. As you might know, like the local host. I'll just write a comment here. Local uh, host is a host is the special name for this machine. Also can use IP address of the machine. Easy. And that is 127.0.0.1. Okay. We are making, so your machine's IP address is this, is the loopback IP address. I mean, you can specify this as your local address, or you can specify this as your um, local host as well. If I replace this with 127.0.0.1, it will be fine. Okay. Then we're printing starting up the local host, this IP and this port. And since we're creating a server, so we can do that. And in this line, we're binding this address to the socket that we
Localhost
created.
1000 10,000
What?
पहले बेस सॉकेट डॉट सॉकेट ये क्या नाम लिखता है ऐसा नेमिंग कन्वेंशन कौन करता है
Okay. So once the socket is binded, so what we can do is that we can listen for the incoming connections. Yeah, so once the socket is connected, we can listen for the incoming connections, and uh, and once we uh, yeah, so once we start listening to the connections, and this is waiting for multiple connections, like it is while true and try. Um, there's a try and there's block. I can make this a bit easier now. Then we can move to the. So this is this will be like waiting for a lot of connections. Like once one connection is closed, I can connect again. But let me start with um, where I can only accept one connection. So let me pull this out. Connection. So first we define the socket. Then we define the server address, then we bind the server address to socket. So now we have created the socket. Once we created the socket, then we can listen on the socket. Like we can say that we're available in this socket point. Let's just listen in this socket. Okay. Um, so then we can this is client address connection dot receive connection dot send all data. Um, Okay, so let's just see like how this thing works. So we've got Python echo server.py. So we have started the server. So server is basically like saying like starting a server is basically like saying that this computer is a server, and I'm accepting data from like in this IP address and in this port number, and whoever want to send me data in this IP address and port number, please make a connection to this and send the data. So since we are designing an eco server, so if you are designing any other server like server serving a web page or something, you can respond accordingly. But since we're coding an eco server for simplicity, we can start with basic thing is that whenever client asks something, send something, we just send it back. Okay. So with that motive, let's say like let's just build echo client py. So in the echo client.py, we'll try to um, code our client. Okay. So yeah. So first we'll import the socket library. There is a chart. Is it needed for the code to be written in a custom manner, or are there any specific libraries or framework for it? So this is the library, the socket library is there. So this is the library. I don't know what else library are you thinking about, but this is the library, the socket library or the socket framework can say. So socket is the library name, but the socket is also something we defined in the network as well. Okay, so this is the host name and the port name. Host name is 127.0.1. That is the current host, and the port is 65,432. This is the system host as well. So you define the host and the port of the client. Okay. Then you start the socket program. So you can do the socket like you can create the object and then create the connection and then close it. That is one way, or you can just use it with with. So with is a block, such that like once you use with, it will be active in that block. Otherwise, it will be closed. If it is goes out of the block, the code goes out of the block. So this is basic like you. So you can use like s equals to or socket equals to this, then socket dot connect, socket dot sendall, all sort of things. But you can also do this like with lock, so that you don't have to write the connection dot close command. Yes, then you s dot connect, you connect to the host. So this is like connecting to the host, and the next is send all. Send all is sending the data, and b we put b to make sure that we send it in byte. And s dot receive. So we have we have wrote a line that data equal to s dot receive. So since the receive connection is duplex, it can send data as well as receive data. So it will send data, and it can also, once the connection is established, you can also receive the data. We'll also receive the data using 1024 bit of data using data. Then at the end, we can print that received data this much. Okay, so like this. Let me create another split thingy. I hope it is visible on your side, and let Python echo client dot py connection diffused. Okay, so port number I need to change 10. Okay, so there is a server's host name or IP address, and there is the port number by the server. So let me change the port number and try again. See, I receive the data hello world here, and send the data hello world again. Okay, Let me clear this up once and clear this up once in the left as well. And I'll diagram, with diagram, I'll let you know how this thing is happening. Let me clean this code a bit as well. I don't want this code to be messy. Sorry. Okay, so let me define the IP and port here so that it will be better. IP equals to 127.0.0.10,000, and let me just copy it from here. Host and port. Maybe 10,000. Okay. And mm, mm, mm. Also, like, let me turn this as the way we designed the client, like with a with command first, and it will be fine, I guess. Bind, listen, accept, then yeah, perfect. Let me draw it for you, like what is happening here. It will be more fun and interactive. Share this screen. So if you have attended my last year's not last year, like last week's live session, you must have known that there is something called TCP connection establishment. So there are three phases in TCP. One is the TCP. So first is connection establishment, and second is data transfer, and third is connection termination. Okay, so there's three pages, and if you have a client and a server, okay, so if you have a client and a server, so what do we need to do? Like so you have to send first, make a connection with the server using a three-way handshake. That is connection establishment. Once the connection is established, you send data across it. That is data transfer, then the connection closure, or the termination. Okay. So well, first let's start with this page. Okay. So in the socket programming, so before starting the connection, so what do you need to establish? What do you need to establish? What do you need to specify that before making this three-way connection? First, you need to specify. So in the server side, you need to specify what is the server's IP, or host IP, right? Then second is server's port. Okay. So these two things we're doing by specifying the host as equals to 127.0.0.1. So the reason we're specifying this 127.0.0.1 is because it is the IP address of the current system. If I'm using my system, my IP address is 127.0.0. Your will also be the same. It's called the loopback address. You can read it in the internet what is loopback address, but it is like I'll describe it shortly. If this is your computer, you are sending data. Okay. So yes, let's say you are sending data from one part of the application 1 to application 2 in the same system. So if you specify the IP address as 127, it will go from application layer to the transport layer, then application layer, then DLL layer. In the physical layer, it will come here to the application 2. So here, our application 1 is the client, application 2 is the server. Since the application 2 or the server is on the same machine, we will specify the IP address as 127.0.0.1. So if it were like at somewhere different address outside the computer, we could have specified something that will go to another computer and it will go through the layers, the application layer. Okay. Since it is the same computer, the IP address will be the 127.0.0.1. And the port. Second part is the port. So port is also like we need to specify. This is the IP address here, but the port we need to also specify, which will correspond to the application. And the port number. So there's something called privileged ports. They're like PRIVILE ports, and there is something called non-privileged ports. Very obvious. Privileged ports are all the ports that is less than equals to 1023. So these ports are already reserved for some of the systems, some of the applications. All the ports greater than 1200 are available for you to occupy. Okay. So yeah, so that's why we have these ports. We need to specify one of the port, and the port is specified as, let's say, sorry, 10,000. For readability, I'm specifying this as 10,000. You can check it with other things. So which port number will not work? So is there any port number which will not work even if it is greater than 1023? Yes, it will not. There might be port number. The port number which are used by the application, by any of the application in your system, will not work if you try to specify that as your port number. So because it is already in use. But mostly, if you choose it randomly, it will not be in use. So we are fine. Yeah. Then creating the socket. Creating the socket is carried out by this line of code. I'll just write it because yeah, I cannot set the code on this page directly. So there is socket. So S equal to socket. That is socket dot AF inet. Then socket dot sock stream. Okay, so once we're specify the server's portion IP, we need to know that we are doing this three-way handshake thing, right? We're not doing UDP thing or anything else. We're doing three-way handshake thing. And once you know that you need to do the TCP, you need to specify that we need to have a TCP connection, right? Give me a second. Give me a second. Okay. So this socket thing that I was saying, yeah. So socket dot socket, yeah. So you need to specify that it's a TCP connection. So to specify that, you need to write this socket dot socket, and you're specifying the socket. And here, this is saying that the connection will be IP version 4. And this is specifying that the connection will be TCP. Sorry. Let me share my screen. Yeah. So the socket dot socket is sort of specifying that this is the TCP. Okay. Once it is, we have created an object, we need to bind it to the host and port that we have already figured out. So that will be done by s dot bind host and port. Okay. So now what we have done is that we have said that, okay, there is a computer, and this computer has a certain IP, certain port number associated with the application that we're trying to design. So now this is socket, and this is binded to the computer's internal kernel, and it is open for business. After socket.bind, there is socket.listen. So it will start listening for the connection. Listen is for that. So once it is listening, so it might get all this connection request. Yeah. So what you do is that we put the with block to make sure it will not be closed. But once it is listening, so what we can do is that we can put it in a while loop as well. It should once it is binded, it's not like that it will listen for forever. We can put it in a block, it will listen after 10 seconds for any message or any connection request or any invitation for connection request. since it is listening every after every some time interval, it will get some connection request, right? So once it is started listening here, the server is set up, it is done. Now if this connection comes for the first three-way handset, it will be listened and received by the socket, and it will send a response. So all these things you don't need to hard code it, but once it is listening, we can write this line of code, that is connection dot connection and address equals to s dot accept. So this line serves for this three-way handset. Okay. So s dot accept is like, accept the connection, send something else, you receive something else, and the connection is established. So yeah, so this connection is established, and this is the connection established that is done by this accept thing. So once the connection is done, what we can do is that we can send the data by putting the connection as with connection. That means in this connection, and also like this is the address that will that this is the client address. So this is the address of the client who is trying to connect. So so with connection, what you do is that we receive the data. Data equals to con.recv. Recv is the function. 1024 is the number of bytes it is expecting. Okay. So we can say if not data. So if there is no data is coming, we should just break. Otherwise, if there is data, then connection dot send all data. What I'm building is the echo server. In echo server, there is client, there is server. If you send hi, it will send back hi. If you said how are you, it will send back how are you. Okay, just echoing the server. Okay, so this is the setting that we have. And coming to the client side will be the same thing. Like we need to specify the so you need to specify which server's host and port you want to send the data to. Okay, so that is specified, and also like we'll get the socket like this, and we connect to the host and port. Okay, so here we are binding the host and port. Like here we are saying that okay, this host and port is binded, but in the client side, what we'll do is that we'll do s dot connect. Okay, so once we do the connecting thing, so s dot connect in the client thing will go through this pipeline and will be listened by the server. Okay, once we connect to this, we'll send the data by send all, and we'll receive the data. So this data will be received using the data dot s dot receive. Okay, and we can print the data in the both sides what we have received. So what to run this, what you can do is that you can open two terminals on your computer, and you can run server in one terminal, and you can run client in another terminal, and you can send or receive data between these two terminals. Okay, so I'll share the computer screen now, and I'll show how it is actually looks like. I've seen that. That is that's the meeting thing. Yep. In case of loopback address, how to visualize the data. So Bipul Sharma send the message in the group chat so that everyone can see, and so that everyone will get the message, and they can also contribute if they like, or like they can also, if they have this doubt as well, they can they tell me that will be resolved too as well. Okay, so okay, so the question is in case of loopback address, how to visualize the traversing. Yeah, I just said that, like in the loopback address, it will start at this application layer and then go to the same computer's transport layer, network layer, DLL layer, physical layer, and it will move back. Since the IP address is the same computer, it will move back to the DLL transport network transport application. Okay. Let me share the screen now. Yeah, this is the client, this is the server code where you are specifying the host and port, creating a socket. Yeah, you can choose to comment this out. Yeah, you're creating a socket. So the final thing is that there is a connection dot close. You see this line? I commented it out. If you don't want to use the connection dot close, you just use with this. So instead of creating a socket then closing it, you can do with this. All the things inside this block will be so this thing will be active. The S will be active inside this block. Once the interpreter goes out of the block, it will be closed. So yeah, so this connection dot close will be automatically happening. So you don't need to worry about it. And as I said, like you first need to bind to the, so you create the socket object, you bind to that. Once you bind to that, you listen on that address. This listen command will keep on listening till there is a connection. Okay. Once you get a connection, you accept that, and you say that we're connected by this address, and then you start receiving the data as long as it is coming. So if the data is not there, you break the connection and send all the data. Okay, so I'll just show you. So first, let's just don't send any data, but so let's just wait for data to collect. So let's say data equals to input, enter the data to send. Okay, and we can do it here as B data. Let me, I'm not sure how to, yeah. Yeah, so we can take the bytes of data and send it. So yeah, let me open my terminal and let me run the server. The server is running. Okay, so the server is running. You can go to the, I can split it right. Yeah, the server is running, and yeah, let me close it. Yeah, let me close it and let me so that I'm listening. Okay, server started. Okay, server started here in this port address. So let me just start the client as well. So I do Python echo client.py. So you see h.connect. So this is the connection establishment phase. Okay, you can say print this, print connection established. Also here, print connection established. Okay, let me cut this thing and clear, and run it. Already in use. So let me just change this to 1001. So there might be some ports already in use. So you just have to be smart about it. Yeah, the server started at this address. Then you start the client. Okay. So in the start the client, you are connecting to it, h.connect, and since it was listening, the connection is established now. Okay. And so connected to this address, connected by this address. Okay. So as a client, you are when you are sending a packet, the packet is sent from an IP address and the port number. IP address we are specifying, but the port number will be picked up by the OS, and also I think IP address also picked up by the OS. And this is the host, like the server's IP address we're connecting. So the IP address used by the client is 53,424. Okay. So now it is waiting for some data to send. And if I send the data, enter the data, it will be sent to the server, and the server will receive the data and send it back. Okay. So if I say, hi, This is yeah. So it is not printing the data. So I should print the data here. Print received data R. Okay. So and it is sending it back, and the send all data is p data, and it is sending it back, and I am receiving the data as data. Okay. So let me do it again. Okay. Let me send the data high, received high, then send it the high back, and I'm getting high. Okay. So let's create something fun. So something like, if I send one, it should send me back ONU1. Okay. So let's just build that. What I can do is that build converter that will, like, if it is 1, it will be 1, and so on. Let's do it for 5. Okay. And you decode the data. Okay. First we need to decode the data, and then pass the data to the convert. Yeah, we can print the data first, then pass the data to the converter. Uh, uh, yeah, let me see if it is working. Mm, okay. Um, yeah, so let me clear this thing. Yeah, so the server is ready. The server is my client. Okay. If I'm sending the data as 1, I should get as 1. Let me send 4. I'm received 4. See, I'm sending the data 4. I'm receiving the conversion of 4 into alphabets. So it is like that. So so you can modify your code accordingly and get all sort of replies along with it. But yeah, so this is some basic um, way of communicating between the clients and server. So yeah, so while you are so yeah, we'll take a short break since we're like talking like um, quite a while. So yeah. Then we can do some multiple connections as well. Okay, let me take a break, short break. And we will not take any short breaks actually, like we can end the session in a quite few minutes. If you have any doubts, you can tell because the multiple connection one is a bit lengthy. I don't want to spend another hour or so explaining it because yeah, it's a bit lengthy. So um, I can cover that next time, like chart windows and all these things, chart servers. But I will not be covering it today. So if you have any doubt, you can put it in the chat. I will try to answer them. Otherwise, we can close the meeting for today. Also, like for everyone who have joined new, all these videos are uploaded in the YouTube channel. I'll share my link to the channel. If you're new, you can subscribe and get all those videos. You can subscribe to the channel and you'll get amazing videos if you like. You got questions? Okay, so code. Okay, so if you want to share me this code, you can. Yeah, I can. Yeah, so when I upload this video, I can upload this code as well. I'll fill this it a bit. Um, if you want to try now, I can wait and. But yeah, so but it will be better if you. This is named as Echo, but it is not Echo actually. Uh, Echo server doing conversion. If if data is a number with in 1 and 5, else. Okay. So yeah, it was echo the data back. Yeah, perfect. So this is I can share this code actually, but yeah, I would let me go to paste pin. Yeah, I think you can access this one code by going through here. Yeah, so I'll put the client one in the uh, um, YouTube video. You can go to the description of the YouTube video and find the link for the client one as well. Okay, so thank you everyone. I think so. Can someone go to this link and check if the code is still there or like can someone confirm? Okay, anyway, I'll just go to the when I'll upload the video, I can give the code as well. Sure. Okay. Thank you everyone for joining today. I'll close the meeting now.